Okay, so if your cranium wasn't already overflowing with seemingly meaningless terms and motions, for this one we're going to need to learn a new thing, which is the limit comparison test. And the limit comparison test has its own set of rules. So with this one, we have two series, right? We have the series, and then we have the series that we're comparing to. And then we could take the limit as n approaches infinity of this over this, and if this does not equal 0 or infinity, if this does not equal 0 or and does not equal infinity, then whatever happens to that one has to happen to that one. So if that one converges, then this one converges. If that one diverges, this one diverges. So this is the limit comparison test. It's not just a comparison, it's a limit comparison test. And we're going to use this here because if we do a normal comparison, it wouldn't actually work out. Because what would we compare this to? We would compare this to 1 over n squared, right? Because the n's cancel out, so that's like the most similar thing once you remove all the junk. But then how could you make, we know that this diverges because it's a p-series with 2. 2 is larger than 1. We know that diverges, so we want to show that this diverges, so we would have to make this greater than that. But this is not greater. This series is actually smaller because we have something cubed there. So it's not that simple as just, this would turn out to be smaller, and then we couldn't, by just that simple comparison, say that this also diverges, even though we know that it does, just from common sense, because it's similar to this one. So we are going to use that series. We are going to compare it to 1 over n squared, but we're going to use this limit comparison, which is a special type. So let's do that. With the limit comparison test, we're going to have to divide. So we have n plus 1 over n cubed plus n over 1 over n squared. So now we can multiply this out to this numerator in the numerator. So we would get n cubed plus n squared over n cubed plus n. We can divide everything by n cubed because we have n cubed there, it's the largest thing, so that's how we solve it when we're taking the limit as n approaches infinity. Limit as n approaches infinity of n cubed over n cubed plus n squared over n cubed over n cubed plus n over n cubed. Now we cancel everything that can cancel out. We have 1, we have an n left, 1 over n. We have 1, and we have 1 over n squared. We plug in infinity, and we will get 1. We will get 1 because these go to 0. So we have 1, is that not 0 and not infinity? Yes, it's not 0, it is not infinity. Therefore, it is the case that whatever happens to this one also happens to this one. And what happens to this one? Well, it diverges. It diverges because it's a p-series. It's a p-series with 2 for p. 2 for p. This exponent right here is p. If p is greater or equal to 1, then it diverges. So therefore, since this was 1, so not 0 or infinity, whatever happens to this one happens to this one, this also diverges.